Good afternoon to all of you. I am Professor Nagaraju, Computer Science Department, YSR Engineering College of Yogi Vamana University, Prodhutur. So I was the first batch student of JNTU, Anantapur, Computer Science, 89 to 93. So in the contents of today's lecture are Introduction to Symbol Table Techniques, Gate Problems and Solutions on Symbol Table. So next, Introduction to Runtime Environment Techniques, and finally Gate Problems and Solutions on the Runtime Environment. So what is the Symbol Table Manager? So that is what is the Symbol Table Management. A symbol table is a data structure containing records for each tokens. Symbol table is a data structure contains record for each tokens. So it stores information about all the tokens such as, so that is the name, type, size, scope and variable. So that means the symbol table store, whenever it takes the token as an identifier, so it stores the entire information about that token. The name of the token, size of the token, data type of the token, so initial value of the token, a scope of the token, so like this. So this is the thing. So suppose determine the correct use of tokens. It determines correct use of tokens. So suppose if you want to store the tokens, so it uses either correctly it has been stored or not, either you are using correctly or not. So it checks type checking and variable type expressions. So here is whenever storing that in the symbol table, it checks the type, either what type of data type is it, the integer, char or like this. For example, when you are taking the program, at the compilation time, we can find sometimes a duplicate variable, a duplicate identifier, like that. So suppose if we, for elimination of the duplicate identifier, it checks the data type, value and name of the variables or expressions used to record each tokens and collect the information about it. So it locates runtime storage to tokens. The symbol table also, so that is the provides runtime storage at the time of execution. So it stores record for return type of functions, its arguments and its return value. The symbol table also provides, so that is the memory, so for the functions, the arguments and return type values. So the returns pointer for the identifier and null when the no record is found. So suppose when the record, so that is when the token is found in the symbol table, it returns a specified pointer, else it will return, so that is the null pointer of that. So generally the symbol table is created so in the phases of lexical analyzer and syntactic analyzers, right? So and the usage will be done in the, so that is the semantic, so that is in the semantic analysis. So we can use from the semantic analysis we can use the symbol table so more effectively. So for example, you see that int a comma b float c and character z. So this is the symbol table. Just only simple example. So name of the symbol table is A, name of the symbol is A and it is integer type. Address is stored in particular memory, that is the 1000 memory location, right? Or suppose it has some value, so then that initial value also we can store. Or next scope of the variable, either it is a local variable or local variable or non-local variable, or lifetime is also we can store in the symbol table. Everything about the, so that is the keywords or next suppose identifiers we can store in the symbol table. So that is the symbol table is suitable. Symbol table is built in lexical and syntax analysis phase. The symbol table is built in the lexical and analysis phase of the compiler. It binds name to objects. It binds names to objects. That means object means it contains a set of characteristics, right? So that is the symbol table is searched every time a name is encountered in the source text. The symbol table is searched every time a name is encountered in the source text. Suppose whenever you find the variable or some data in the text, so immediately that will be searching in the symbol table, whether that is a correct or not, like that. So it will be changed if a new name or new information about an existing name is declared. So it would be changed if a new name or new information about an existing name is declared. So for example, if you are given that, suppose initially we are taking for finding the sum of n natural numbers. Initially we can find the sum s is equal to 0. So after execution of the program, suppose when you are given one number, the value of the sum may be changes. So that is the sum of the value may be changes. Whatever the values are changes, that values will be rewriting in the symbol table. So suppose if you are not using that variables will be deleted from the symbol table. So that is the storage of tokens. But in what format the variables, so that is the identifiers will be stored in the symbol table. For example, here is the one is the fixed length tokens, one is the fixed length tokens, and another one is the variable length tokens. So the fixed length means the size of the memory should be fixed. For example, when you are using the integer, it occupies 2 bytes of memory, or float 4 bytes of memory, character, so that is the 1 byte of memory. So the nowadays integer also occupying 4 bytes of memory. So that is a variable length record. Variable length record means this is depending on the execution time. So the size will be varying. So for example, when you define the structure, or so suppose when you are using the pointers, so at the execution time the memory size may be increased or decreases. So that's why, so that is the tokens may be either fixed length tokens or variable length tokens. So depending upon the type of the token we store in the symbol table. Responsibility. What is the responsibility of symbol table? What is the responsibility of symbol table? It maintains all declared names and their properties like type, size, etc. The main responsibility of the symbol table is it maintains all the names. So that is with their properties like name, so that is the type, size, scope, or like that. It is used to retrieve the properties of a names. It used to retrieve the properties of names. So these two are the main responsibilities of the symbol table. So that is the content of the symbol table. What the symbol table it contains. So for example, one is the object nodes, structure nodes, and scope nodes. But here is activation tree we can use. So that means here is object node. Suppose when you are using the parse tree or syntax tree or dependency graph, so we can call it as a nodes, right? Each and every token will be represented as a node. So token. Object nodes. Object node means it is a, suppose when you are taking the object means it is a single variable or single identifier. So that is a collection of properties with that name is called object. So that means we are saying that the object is a runtime entity of the program. So that is here is the runtime means the object contains a set of properties and functions. So that means whatever you are given that variable, suppose if you are given, so that is a float x. So that is the properties of all properties of x will be stored in the thing. That is called object node. So that means it is a single data type, name of the variable, type of the variable, value of the two variable, and scope of the variable. And structure nodes. So structure node means sometimes we can use a set of objects can be represented with a single name. So that is either you can use the arrays or structures. So if you want to represent the structured variable, we can use the structured nodes. And scope nodes. Scope node means, for example, suppose when you are declaring the variables in the functions or in the main program. That means here is the variable may be either the local variable or static variable, register variable, or external variable. So that means depending upon that scope. So that means here is when you are using the functions, suppose what are the variables of the functions, what is the scope of that function can be represented with the scope node. No? So in this case, suppose whenever the function enters, it specifies the scope begin and scope ending. So within that, whatever you write, all will be activated at a time, all will be deactivated at a time. So that is a symbol table that contains the objects, either the fixed length or variable length, or the formats of this fixed length and variable length are object nodes, structure nodes, and the scope of the values. Operations of symbol table. Suppose what are the operations we can perform on the symbol table? Generally we can insert. Suppose whenever you find the identifier or token, so simply we have to insert the token into the symbol table. That is the insertion operation. That is the string key and the object binding. Suppose when you are taking that object and the string key means, so that means the string key, that is operation, that is the name of the token, and here is the reference number. So in the beginning I explained that that is the name of the token and the reference number in the symbol table will be specified, and so then we can insert that into the symbol table. And object lookup. So suppose in the syntax tree definition. So suppose if you want to set the, so that is the syntax structure of the program, we have to collect the data from the symbol table. Suppose for this purpose we can use the object lookup instruction. That is the instruction we can use string of key. That means when you are given, suppose if you want to get the particular identifier A, so then we can look up in the lookup table, we can search for that. If you find, we can retrieve, otherwise it will display the error message. So that is a begin scope and end scope. Begin scope and another end scope. For example, within the program we can use a number of functions. So the scope of the function, or that is the scope of the function is limited, right? The variables and statements which are writing within the function that are local to that function only. So whenever the control enter into the function, it will execute, else it will be, so that is the remove. After exiting, all will be destroyed. So that's why all the function variables and statements will be, all the function tokens will be stored in between begin scope and end scope. So next, handling the reserved words or keywords. But how to store the keywords? So directly the keywords will be stored as it is. Suppose if the plus sign is there, so plus, that will write only. So plus is the token and name is also, identifier is also, name of that is also plus. Insertion, so that is a minus and minus, or for loop and for. So that is here is simply we can use whatever the keywords we are using, the without changing that name, automatically that will be stored in the values. Here is the plus and minuses are leg jumps and other tokens. These are the leg jumps we can use. I think I understood that operations of symbol table. So that is the inserting string, object binding. So that is the insertion operation. So that is the lookup operation, begin scope and end scope. There is another one is also we can use the delete operation. Suppose sometimes we can delete automatically, it will be deleted. So these are the operations we can perform on the symbol table. So that is, but in the symbol table we are using lookup, so that is object lookup operation. That means searching operation. So if the symbol table is there, but how to pick the element? Suppose token. Suppose in the semantic analysis, if you want to construct the syntax tree, so in that cases you have to collect the information about the token from the symbol table, and next that attached information for the parse tree, then you have to generate the syntax tree. So for getting that, if the symbol table maintains a large number of tokens, so then the searching time will be more. So that's why what type of data structures we can use for insertion of token into the symbol, or searching for the particular token, or deletion of the token. So for that purpose, here is the different data structures we are using for that. I think already you have studied all the things. Suppose in the first year beginning, in the data structure, you have studied everything. That's why here is briefly I am explaining this. So that is the first one is you see that linear list organization, self-organized list, balanced search trees, hash trees and search trees. So that means these are the different linear search. Suppose the linear list means, so that all the tokens will be arranged in a linear fashion, so that we can search for, so from starting to ending. And self-organized list means it is nothing but a linked list we can use for implementation of symbol table. And next is search trees means we can use the binary search, ABL trees like that. And next the balanced tree means B trees or B plus trees as we can use. Another one is the hash table, hash symbol table we can use for this one. So the depending upon that application we can use any one of the structure. But each and every data structure is having its own advantages and its own disadvantages. So that is briefly I will explain what are the advantages and what are the disadvantages of each and every operations, right? So generally everyone is familiar with the linear search, right? Linear search, Fibonacci search, binary search, binary tree search, AVL trees, B trees, AVL trees, red black trees, split trees are we are using split trees. or next that is the B trees and B plus tree, after that ash, right? But only these are depending upon the time complexity and the functions. For example, first one is the linear list. Linear list means, so that is the linear list. So for searching of that element, either we can use the linear search or binary search or otherwise Fibonacci search, right? So but when you are using the linear list, suppose in the linear list, if all the table of constructed by using a linear data structure, suppose linear data structure means arrays. Linear data structure means arrays. So in that cases, we know that already, suppose the continuous memory locations we have to use for storing the values, right? But when a linear search is very easy, suppose linear search. So we start with the first location and searching for up to end, up to n elements. So at any case, you can find the element. But here are three types of cases. The best case means if the element is found in the first, if the element is found in the first location, we can call it as a best case. If element is not found case, we can call it as a worst case. And other than this, we can call it as a average case, right? But when you are using the linear search, the main drawback of this one is if the number of elements in the symbol table are increased, so that definitely the time complexity will be increasing. And the second one is the searching of the element. Or next, suppose if you want to insert element at the end, there is no problem. With a single order of n, we can insert it. Or so suppose if you want to insert element at the front, so suppose at the beginning, so all the elements should be moved right side by one memory location or one position. So if there are n elements are there, for shifting it takes the n nanoseconds. So for inserting it will take like this. So that's why here is, so that is that will take the more time than this one. Insertion process will take a more time. So for avoiding that, we can go for binary search tree. Suppose in the searching, in the linear search, so if the number of elements are more, that will be problem. So there is a binary search you can go for. In the binary search, what you are doing? So suppose we are taking the list, we are making that into ordered list, we are dividing that into two parts, and next we are searching at the left side or right side. For example, when you see the dictionary, if you want to find out the meaning of word, W-O or the word, otherwise you take the world. Suppose if you want to find out the meaning of that world. So the first case is in the linear search, we have to search from first page, second page up to, so that is the large W page, right? The page which is having W, but it is a time taking process. So instead of that, we can use the binary search trees. So in the binary search trees, we can divide that into two parts. And suppose if you open the dictionary, half of the part, suppose it has come R, that is the word, so that is the page which has come and stored with the R. So that is from A to R we can delete it, and next R to Z will be searching. So that here is, if there are 10,000 tokens in the symbol table, so only 20 comparisons are sufficient for finding whether the given token is in the symbol table or not. But when you are taking that binary search, there are some, so suppose binary search, there are some problems. So you must arrange the elements either in the ascending order or descending order. So that is also, it takes order of n depending upon some programming languages, order of n square or order of log n base 2 or something. So second one is you required, so upper limit and lower limit. So next third one is, there we are using the costly operator, that is the costly operator, that is so that is the a low plus high by 2, that is division operation is the high cost operator. So because of three drawbacks, we can go for Fibonacci search. In the Fibonacci search, the costly operator division is replaced with a plus. Division is replaced with a plus. That means a strength reduction. When you are reducing the strength, automatically the searching time will be reduced. So after that, but there also we must know upper limit and lower limit. We must know the upper limit and the lower limit. Without knowing upper limit or lower limit, it is not possible to find out. So that's why we can go for binary search trees. We can go for binary search trees. So in the searching time, when we are using the binary search tree, we start first we can construct the binary search tree. And next we can start with the root node. We can start with the root node. Either we can search in the left side tree or we can search in the right side tree. So that is left side tree values are always less than or equal to its root, and right side values are greater than its root values. So that's why here is half of the tree can be eliminated at every time. So that's why even there may be number of elements are there. So it takes the time complexity of order of n, order of log n base 2. But here is in the search binary search tree, there are some problems are there. What are the problem? Suppose if I given all elements are in the ascending order or descending order, there is a chances of getting only left skew tree or right skew tree. So that means left skew tree or right skew tree. But when you are getting the left skew tree or right skew tree, so generally the time complexity will be same order of n, that is equal to linear list. So to avoid that, so for construction of balanced tree, we can use AVL search trees. In the AVL search tree, already you know that. So in the AVL tree, every time the left subtree length and the right subtree length difference must be always less than or equal to 1. If that is the levels are different, then we have to rotate it. So that is the AVL search tree, right? Suppose when you are constructing the AVL search tree, definitely it reduces the time complexity of this. But what are the drawbacks of using that AVL search trees? Suppose every time, suppose if the tree left subtree and right subtree length is different greater than 1, every time we have to, so that is the shifting. So that is you have to apply the shifting rotation operations. So that it takes more time if the element same thing for ascending order elements or descending. For avoiding that, we can go for red-black trees, right? I think either you have studied or not, I don't know. So we can go for red-black trees. That is in advanced data structures, I think you have studied. Red-black trees are there. In the red-black trees, there are with some rules, this relaxation has been given. So that is the length of the left subtree and right subtree always less than or equal to 1. But that relaxation will be done in the red-black trees. But there also there are some problems. So suppose because there are also construction of making the root node should be a red node, red node or black node or red node, black node. There are some rules are there. So that's why we can sometimes, so we can go for splay trees. Splay tree means here is the tree. Suppose if you want to perform the same operation, suppose insertion 1000 times you are performing the insertion operation other sequentially, or 1000 times we are performing deletion operations from the symbol table. So then it gives a better time complexity than binary search tree, AVL trees, red-black trees. So that's why, so depending upon that we can use the splay trees. But these are the splay trees. Suppose when these are splay trees are, so that is all the trees are used for searching in the primary memory only. These trees are used for searching in the primary memory only, because the primary memory size is very, suppose 32 GB, 128 GB or 256 GB, 1 TB or maximum of that. So there is a no 1 TB are not there. Suppose here is the primary memory is very limited. So that's why here is we can use the binary search trees. So suppose where you are using the balanced search trees, B trees and B plus trees. So, but suppose in the secondary memory there is a 1 TB or 4 TB hard disk is there. So in that memory, if you want to search for a particular token in the symbol table, but the tree length will be increasing while you are using such trees. So that's why we can use the balanced trees or MB trees, B trees or B plus trees. That is the index trees we can use. But in the DBMS, I think already I studied B trees and B plus trees, right? So that is the balanced trees are B trees and B plus trees or MB trees we can use. As table, suppose here is, but when you are using that, so then next here is self-organized list. Self-organized list means it is a linked list. Suppose insertion, deletion, searching should be so the different. Suppose if you want to insert the element anywhere, so like array, you need not to shift elements on left side or right side. Directly we can go to that location. So simply we can remove the left element link and right element link, and next these links will be connected with the new added node of this, right? So I think you are familiar with all these linear search trees, linear searching, a self-organized list, the balanced search trees, and search trees. The linear list, suppose binary search tree, binary search, Fibonacci search, and linear search, you have studied in the linear, and self-organized, already you have studied the linked list, right? A single linked list and double linked list. Our next one is for searching operations. You can see that here is searching. Already you have studied binary search trees, or graphs, AVL trees, play trees, B trees, B plus trees, and like this. Balanced tree means are this one. But when you are using the hash, so suppose here you take that hash symbol, suppose in the hash symbol, so that is the searching time is order of 1. It doesn't depend on the size. So nowadays in the Google also we are using hash tables, right? So then you see that, so these are the techniques we can apply data structures for implementation of the symbol table. I think already you have studied in the data structures. I don't want to go in depth about this. So this is the linear list. Use array to store names and associated information. It allows continuous memory location. Insert object lookup operations are performed. Cost of the search is order of n. The worst case is order of n squared. So that is here in the list. Suppose if I taken this is the our employee list. Suppose I taken these are the tokens and the corresponding information will be stored, and so then you can perform the list. A self-organized list means it contains additional field, that is the linker to each record, field and each array index. That's why here is we can use. So that is the linker field, right? That is the linked list already we have studied. That is if the arrays are implemented by using linked list, we can use the linked list. And trees, we can use the binary search trees, ABL trees, red flag trees, play trees, and the next B trees and B plus trees. So these are also used for searching of the things, right? So this last one is the hash table. But here is the hash table is a better than among those. So one is the operation, so that is the open a hash table, closing operation, insertion, deletion, and the searching operations. But when you are using the hash function, the worst case and best case, it takes the order of 1. Order of 1. Even there are 10 millions of records, but it takes only one within a single attempt it will pick the element. So that means I don't want to go in depth because already I studied this table also. But here is, but what are the problems of that hash tables means? One is the linear probing and another one the chain by, so that is the separating list. Suppose here is the collision operations. Collision operations means, for example, when you are taking this is the hash table and this is the symbol table. The location information, that is the name, information and link, so will be maintained in this case. But here is, so that is generally in C program in the data structure we can call it as a bucket sorting. You can call it as a bucket sorting or partition sorting. So then here is we can use this. So the entire memory will be divided into number of things. Suppose if there is a hash table, suppose by 10 we can take. Mod function we can use. So that is any value by 10 means suppose, so if you are getting the remainder is 0, that value is stored in the 0th block, or what remainder is 1 in the 1 block, remainder is 2 in 2 block or 3 block like this. So the elements are stored in separate memory locations. That's why it increases the execution speed, but there are some collision operations are there. One is the linear probing and chain probing of this. So with the help of this we can implement the symbol table. I think I have understood that. So, but here is the most of the cases, this is related to the data structures, right? So that is the maintenance of data of this. This is the, so that is the symbol table, right? Briefly I explained already, you know that implementation part. And some of the gate problems on this one is, first you see that, so that is the select a mission independent phase of the compiler. But here this is not related to, but so that just what I am explaining. Select mission independent phase of the compiler. Which one is the mission independent phase? So the syntax analysis, that is the front end is always mission independent. So that is the syntax phase is mission independent, and intermediate code generated is also it is a mission independent, and so that is the language independent. And the lexical, so syntax analyzer is a language dependent and mission independent. Lexical analyzer is a language dependent and mission independent. That's why the answer for this one is all. So that is equal to answer is D. We can use the answer is D. Second, you see that the question, by whom is the symbol table created? By whom is the symbol table created? That means so that is there are different compilers are there, interpreters are there, assemblers are there. So that is here is, but when you are using that, which one will create the symbol table? But here is the symbol table is created by the compiler. The symbol table is created by the compiler. But when you are taking the interpreter, so it interprets the data statement by statement. So at that time you need not to store the data in the symbol table. Most of the cases, suppose very few amount of data we can use like this. Our assembler is also maintain the data, but these will be maintained a symbol table in different ways. So that's why. So that is by whom is the symbol table constructed means we can input is the answer is compiler. Answer is the compiler. But if you are given all of the above, the answer is all of the above. But in every phase, that will be giving. So that is answer. So that is the giving correct. Every phase, suppose compiler construct the symbol table, interpreter also constructing the symbol table, or assembler also constructing the symbol table. But these symbol tables are different. But here is if I given all above are correct. So then D is the answer. None of the above means suppose here is the answer first preference will be given to the compiler. That means the compiler create the symbol table of this one. So that is the symbol table is created by the compiler which contains the list of lexems or tokens. So second one is done. So that is the third question. Which of these is not true about symbol table? Which of these is not true about symbol table? So here is the only you can get the theoretical questions. So that's why if you are good at a symbol table, then easily you can answer for the question. Suppose here is only straightforward questions are there. So there is some more later I will explain that. So that is which of these is not true about symbol table? It means all the labels of the instructions are symbols. All the labels of the instructions are symbols. The table has entry for symbol names and address values and performing the process of the assembler directives creating during process 1. So that means which of these is not true about symbol table. Then you see that all the labels of instructions are symbols. Table has entry for symbol name address values. Perform the processing of the assembler directives. That means creating during process. That means the symbol table created during the pass 1, that is in the front end phase. All the labels of instructions are symbols. Yes, all the labels are symbols. Table has entry for symbol names, address and values. Yes, but the third one, perform the processing of the assembler directives. C is not correct about the compiler. C is not correct about the compilers. You see the fourth question. Which of these features of assembler are mission dependent? Which of the feature of assembler are mission dependent? Either that is the instruction format, suppose you got the, so right here. Instruction format, so mission is a mission dependent means assembler language is a low level language, so definitely it is depends on the missions. So that is the instruction formats, address modes, program relocation and all of the mentions. So that means which of these features of assembler are mission dependent. So all are mission dependent because instruction format. Either you are using 3 address code or 2 address instructions like that, right? Addressing modes. So suppose depending upon the assembler, you have to use the addressing mode. Either indirect addressing mode or direct addressing mode or immediate addressing mode like this. Program reallocation. Suppose if you want to reallocate so that is the executable code from one place to another place, that is also depending on machine. So that's why according to assembler, so these are the D is correct answer. The symbol table implementation is based on the property of locality of reference is. The symbol table implementation is based on the property of locality of references is linear list. That means locality of references means and nothing but the hierarchy of the memories. The register, cache memory, primary memory or secondary memory and virtual memory like that, right? So the linear list, search trees, hash tables and self-organized list. So suppose here is when you are taking that the symbol table implementation is based on the property of locality of reference is. So that is hash tables. So that in the memory management in the runtime environment I will explain about what is the locality of references, right? So here is the locality of the references means so that depending upon that memory the hash table is implemented. But if the hash table is stored in the, so suppose primary memory, so then automatically it will be searching time will be increasing like this. That is, this is symbol table. So these are the previous questions in the gate and so suppose DL or some other language. Symbol table implementation is based on the property of locality of references hash. So that is a hash one. Seventh question is here. Access time of the symbol table will be logarithmic if it's implemented by. So that is the logarithmic means log n base 2, n log n base 2 like this. No? Access time of the symbol table will be logarithmic if it implemented by suppose what? Linear list. So what is the time complexity? Order of n, order of linearity. Linearity is increasing. Search trees, that is the binary search trees. And the second one is the hash. Binary search trees means, so that is the log n base 2, right? Generally this is the hash means order of 1. Order of 1. So that's why, so next one is the self-organized list. Self-organized list is also a linked list. It is also taken order of n. First case, it takes order of n. And here is the linear list. It takes the order of n or sometimes n square also it takes, but in the case of insertion, the searching, so B is the correct answer. Access time of the symbol table will be logarithmic if it's implemented by such trees. That means answer is B. That is answer is B. So searching tree is the logarithmic. Already everyone knows that because in the DA also we are studying same thing. So eighth question. Which table is permanent database that has an entry for each terminal symbol? Which table is permanent databases that has an entry for each terminal symbol? So that is different symbol tables you can mention, that is the terminal symbol. The option is, here is the name itself specifying the terminal symbol. So that's why A is a terminal table, literal table, identifier table and a reduction table. So internally again the symbol table may be divided into number of subtables. So that's why here is all the non-terminal symbols and terminal symbols, literals, identifiers, everything will be known. So that is for this one answer is A. Which table is permanent addresses that has an entry for each terminal symbol? That is the terminal table we can use. The correct option is A. Symbol table can be used for. So today I am going fast because so already I studied all in data structures and as well as in the. So the morning class madam also explaining all these things. That's why briefly I am explaining. A symbol table can be used for what? Checking type compatibility. A. B is suppressing duplication of error messages. And C, storage allocation, and D, all of the above. Answer is D, all of them. Suppose symbol table can be used for checking type compatibility, it is correct. Suppressing duplication of error messages. So suppose if the same variable is declared as an integer or float, so then it separates the variables and storage allocation. It also concentrate on the storage allocation. So the latter will go in depth about runtime environment, right? So next one is that is option is D. For the ninth question, option is D. So next you see that question number 10. So that is a GATE 2010. So that's why directly I copy pasted this one. So that is a compiler design, compiler GATE 2010. Which data structure in a compiler is used for managing information about variables and their attributes? The 2010 they got this question in the GATE. Which data structure in a compiler is used for managing information about variables and their attributes? Obviously, it is a symbol table. Abstract syntax tree, it contains the information as well as parse tree. So the semantic stack, so that is also stack. So parse table, that is also used for parsing. But here is we are using the symbol table, right? So the symbol table, parse tables are used to construct the parse tables. So already I explained the LLR grammar and the LA, so that is the LL grammars are top down bottom of parsers like this. I think two grammars are there, LALR and CLR. In the tomorrow's class I will explain those. After that in the last class I will explain all the GATE problems from so that is the first unit to last unit, right? So the answer is symbol table. So take answer is B, that is symbol table. 11th question in 2014 we got this answer. This GATE. Which one of the following is not performed during the compilation? Which one of the following is not performed during the compilation? One is the dynamic memory allocation, type checking, symbol table management and inline expansion. For example, when you take that, so the type checking will be done at the time of compilation, right? In the semantic analysis. So the symbol table is constructed at the phase 1, either in the lexical analyzer or syntactic analyzer phase. During that phases, we can construct the symbol table. Inline expansion. At the time of lexical analyzer, the inline functions are expanding. But here is the compilers cannot implement that in dynamic memory allocation. But the compilers always implement in the memory management static. By default, if you want to change that, we have to use pointers or something like this. That's why answer A is correct. Which one of the following is not performed during the compilation? That is A is the correct answer. That is option. Dynamic memory allocation cannot be performed at the time of compilation. Question number 12. In 2-pass assembler, symbol table is constructed at first. So that is the symbol table is constructed in 2-pass assembler. Symbol table is constructed at the first phase. That is the answer is A. So suppose when you are using that, answer is A. Generation in the first pass. Here is we can use the first pass and the second pass. So that is in the first pass we can construct the symbol table. In the second pass we can construct the mnemonics, the values. That's why here is we can use the answer is C. Uniform symbol table. Uniform symbol table. What is the meaning of that uniform symbol table? Contains all constants in the program. Uniform symbol table means contains all constants in the symbol table. Option A. Option B is a permanent table of division rules in the form of patterns for matching with the uniform symbol table to destroy syntactic structure. And C is consist of full or partial list of tokens as they appear in the program, created by lexical analysis and used for syntactic analysis and interpretation. And fourth D is a permanent table which lists all keywords and special symbols of the language in symbolic form. So that's why here is answer is C. So that is when you are taking that. So that is the consist of full or partial list of tokens as they appear in the program, Generally, that is the symbol table means it contains all the variables and keywords which are used in the program. That's why answer C is correct. 14. In two-pass assembler, the symbol table is used to store. So that is a two-pass. That is the second phase of this one. We can use for numeric labels and values, only values, memory locations, or mnemonics. So generally, that is assembly language uses mnemonics. So in the second phase of the compiler, pass of the compiler, it uses mnemonics. That is the answer is C. Sorry, answer is memory location. Sorry. In a pass assembler, the sum table is used to store memory location. That means here is, so that is for all the mnemonics, it will convert it into memory locations. So these are the symbol table, because the symbol table is related to data structures. That's why I explained very fastly. So second one is the runtime environment. So next one is the runtime environment we can use. So in the runtime environment, exactly this is the last part in the compiler design. So that is the fourth generation, already I explained. So that is the compiler must do the storage allocation and provide access to variables and the data. Generally, the compiler must do the storage allocation and provide access to variables and data. The main function of the compiler is it takes the high-level language program into low-level language, and so during that it stores the data in the symbol table, or it uses the memory locations. It also performs the, so that is the insertion deletions action. So next to memory management. So in that case, we can use the stack allocation, heap allocation, and garbage allocation. So first we will study about that memory management. But here is when you are executing the compiler must concentrate on two things. So one is an operating system as well as on the memory management. But here is, suppose when you are executing the program, but that program will be so converted. Suppose when you are taking that program, so here the program is divided into, for example, any program execution. So that will be for execution of the program, that is divided into 4 stages. Memory is divided into 4. Right? So the first one is here is this can be used to store the data, entire program, and this is for global data. And here is we are using the stack. When you are using the function stack execution, and here is we can call heap memory. So that is the heap. So here is, but here is suppose when a compiler, so it has to, it depends on the language and next operating system as well as in memory management. That means these modules should be included in the compiler. So that is a very important. Suppose, so that is at the time of construction of symbol table, it has to identify the memory and it has to identify the data structures. They have to create a symbol table. So suppose if you want to store that program, either high-level language program or low-level language programs, so again we have to use the memory management, and that is also depending on operating system. So that means while you are designing that compiler, you should concentrate on 3 things. One is the language, one is the operating system, and another one is the memory management. But operating system is also a one kind of software. So that's why you need not to bother about that. But here is, suppose when you are in the memory management, so that is here is, so how to allocate the memory for the program and how to deallocate the memory is the main, so that is the topic in the compilers. That is called runtime environment. If you want to execute the program, what kind of environment you have to provide. So that means one is the operating system, one is the memory management. The basic functions of memory management are allocation of the memory and deallocation of the memory. For example, when you are using the program, so that is you have to allocate the primary memory. You have to allocate the primary memory. So whenever after completion of that program, you have to deallocate the memory which is allocated for programs. That only 2 functions in the memory management will take allocation and deallocation. But in this case, so that is you have to concentrate on more. Why? Because the memory is very limited to the computer. But if you want to execute a large number of programs, you have to go for virtual memory concept. But when you go for virtual memory concept, definitely the execution speed will be reducing. So that's why here the memory manager can allocate or deallocate the memories. So in what way that will be allocated? The properties of memory managers are space efficiency. That means the memory should be used effectively. So that is the space efficiency. Second one is the program efficiency. So that means here is the while you are showing there is a program. So execution, you have to increase the execution speed of the program. That means the variables where you have to store, either in the registers you have to store, or so suppose in the primary memory or cache memory or secondary memory or in virtual memory. But that is the program efficiency, low overhead. So these are the properties you have to concentrate on: this space efficiency, program efficiency, low overhead. So when you satisfy these things, so you can allocate the memory. At the same time, you have to deallocate the memory. For the proper utilization of the memory is so take care by the compiler. But in the old compilers, those do not having, but that is powerful compilers. But when you say that the C program is a more powerful programming language, means it has its own powerful, so the compiler. So for memory management related to operating system and related to programs, right? This is the memory. So that is when you are using a typical memory hierarchy configurations. But when you see that the entire memory is dividing like this based on the speed. For example, registers. When you take that register, that is the register is 32-bit word. Registers are, it will store only 32-bit word. So it takes the process in nanoseconds. In nanoseconds it will execute. Suppose whatever you are given the data, so you can store that in the register, it will execute in nanoseconds. So for example, in the C programming, we have studied register variables. Register variables means if the indexed variable, that is the loop variables are stored within the register, definitely it increases the execution speed of the program. And the next here is the compiler will identify which variables you have to store in the register, first level, cache level 2 or primary or something like this. But the second one is the first level cache. So it will use a 16 to 64 kilobytes. It is nothing but a stack operations. So that is the 16 to 16 kilobytes of memory that will be taking. But here is also for same execution of this program, it takes 5 to 10 nanoseconds. The speed of that one is it will take the 5 to 10 nanoseconds. But 128 KB to 4 MB, that is the second cache. Suppose the cache memories we can provide. So built-in cache, we are calling that is a built-in cache, and external cache we can provide. But when you are using the external cache, that is the second level cache, the range, the maximum capacity of this one is 128 kilobytes to 4 MB. 4 MB. But here is the execution speed is, so that is the access time. That is the accessing time is execution speed. So 40 to 60 nanoseconds. If you want to access a particular thing, it takes 40 to 60 nanoseconds. So 256 MB to 2 GB, 2 MB to 2 GB, that is called physical memory. Physical memory means the secondary memory, that is the hard disk. So that takes the 100 to 150 nanoseconds. For accessing a particular value from the secondary memory, it will take 100 to 10 nanoseconds. So the virtual memory disk, that is the virtual means that is the secondary, this is the primary means it is nothing but, so that is a RAM, we can call it as a RAM or ROM. So virtual memory disk, that is the secondary memory devices, more than 2 GB. Nowadays we are using 4 terabytes or 5 terabytes, 4 terabytes or 8 terabytes we are using. 2 GB, that is 3 to 15 minutes it takes. 15 minutes of time it will be taking. So then you see that, but when you are going to from top to high, so that is the accessing time will be increasing from seconds to nanoseconds to from minutes. That will be, this is nothing but a minutes, not minutes. So that is the nanoseconds to minutes means automatically the searching time will be. But here is what is the function of that memory manager handled by the compiler is, so it takes the program and it separates the variables are next to programming part. So which memory is allocated for which part of the program is decided by the compiler. Decided by the compiler. Suppose if there are so many indexed variables are there, suppose a for loop statement, suppose in array or something, all indexed variables will be stored in this register. So that here is the registers are only 8 general purpose register. Very important things will be stored in the register or next level like this. That's why we are using the cache memory. First level means it is a built-in memory. So second cache level means it is also so that is externally we can fix the cache memory, and the physical memory means either RAM or ROM, or virtual memory means hard disk, right? So that is which will be stored. So that's why while you are executing the program, that will be stored maximum in the physical memory, but not in secondary memory. If you want to store permanently, then only we can store that in the secondary memory, because it takes the execution speed in minutes. This is the hierarchy of the memory. But here is suppose when you are using the memory, so that is the 4 states of memory chunks are available. 4 states. One is the free, not hold an object, available for allocation. That means the free memory. So that is the memory may be free. So free means so it is not allocated to any object. You can use that memory for anything. Unreached memory holds an object but has not yet been reached from the root set. Unreachable memory. So unreachable memory means first it will start with the root. Suppose entire thing in the the compiler will execute the program in the static manner. So that is the static memory allocation. By default, the compiler will allocate the memory statistically. For example, in the first phase and second phase, we are constructing the symbol table. So in the symbol table, when you are using the variables, so that will be waiting in the memory until to get chance to execute. So that kind of variables are called unreachable memory. That memory cannot be used. That memory cannot be used for some other thing until to eliminate that. So next one is unscanned memory. That is the garbage collector. That is unused memory we can use. Reached from the root set, but its reference not yet allowed. So that means in the C programming or in the C++, we can use the pointers. So once we can allocate the memory with the pointer, we have to deallocate it. Suppose if we are not deallocating, it means the memory leakage will be occurred. So that is called unscanned memory. So next is scanned memory. Reached and references followed. Reached and references followed. That means here is the elements are reached and executed. So that's but it is properly executed. So then after completion of that we can eliminate the memory. But in this memory, that is entire memory will be divided into so for uses in 4 ways. One is the memory may be free, that can be used for anything, or unreached memory part. Unreached memory part means so that is in the symbol table. So that is the variables are waiting until to get the chance to execute. So that is so ideally they are sitting in the symbol table. Unscanned means so suppose when we are using the pointers or something, that is the dynamic memory allocation. So after using that objects, immediately that should not be deleted from the memory. So that will be in the one. So then that is called memory leakage. And scanned, that is the reached and the references follow. That is while currently executing for that memory is allocated. That means so 4 states of memory chunk. Whether the memory may be free or memory may be unreached, or memory may be unscanned and memory may be scanned. Locality in programs. Why we have to study the memory means the conventional wisdom is that the program spend 90% of their time executing 10% of the code. Why we have to concentrate on memory management in the compilers means the 90% of the time the program is sending. So that is executing for execution of 10% because of the slow process. Suppose if the data is stored in the secondary memory or virtual memory, so that definitely it will slower than, so that is 100 times slower than CPU. So then automatically it should idle like this. The program often contains many instructions that are never executed. So but when you are writing the program, in the previous class already I shown that GCD of 2 numbers, right? So that is the 7 ways I had written. So that is the first program I have taken 23 statements and last program I have taken only 4 statements. So, but within the 4 statement, when we are writing that, so that definitely, so that is the execution speed will be increasing. But nowadays, so we are writing unnecessary statements within the program, we are increasing the execution speed. So next, only small fraction of the code that could be invoked is actually executed in the typical run of the program. A small function, that is the only small function of the code that could be invoked in actually executed in the physical run of the program. The typical program spends most of its time execution innermost loops and tight recursive cycles in the program. But where in the most of the time that will be spending means in the loops. So suppose in the iterative statement, and the second one is the recursive function calls in the recursion. So that's why. So suppose when you see that a merge sort, we can say that in the worst case, average case, best case, we are saying that merge sort is better than all sorting techniques. But merge sort also having 3 problems. One is it uses 2n memory locations. That is the one problem. And the second one is it follows the top-down approaches. It follows the top-down approaches. But when in the top-down approaches, if the elements are recursively partitioning, and after that again that will be merging. But if elements are less than 16, then it is better to use the insertion sort than merge sort. So that means there are different. So that is according to that memory management, merge sort is not suitable. So that's why we can use in-place algorithm. That is the secondary matter. So that's why here is inner loop and recursive functions are taking one. That's why in the bottom of approach we are following without recursion. We can follow the bottom. The memory allocation. But in what way that memory is allocated? A static memory. That means if the memory is allocated for the variables or program at the time of compilation, that is called static memory allocation. So generally the compiler will allocate the memory at the time of compilation in the symbol table. So the dynamic memory allocation. Dynamic memory element, the memory is allocated at the time of execution of the program. The memory is allocated at the time of execution of the program. That is called dynamic memory allocation. Already we know that what are the differences between static memory and dynamic memory. The static memory is faster than dynamic memory. A static memory is costlier than dynamic memory. And here is in the static memory. So, but here is the memory may be wasted, but in dynamic memory, memory may not be wasted. The problem of the dynamic memory is memory leakage. After allocating the memory, if you are not deallocating, so then it is the problem. But here is the static memory is allocated by operating system, or dynamic memory allocation or deallocation will be done by the users, right? So in the C programming, the pointers already you have studied this. Many compilers use some combination of the following: stack storage for local variables, parameters, and so on. So that is when the program can use the stack. Suppose if the program contains number of subfunctions, so if you want to execute the function will be executed in the stack. So for example, here is I said that suppose here is only thing is suppose here is you see that. So for any computer, so it allocates the memory in 4 ways like this, right? So first one is here is 4 parts. Here is we can use the code. Suppose here is we can use code of the program. Here is we can write code. Here is you can use the code, and here is suppose when you are using that, here is a global declaration. Here is you can use the global declaration of the variables, and here is you can use the stack. Memory can be provided. Stack, and here is the heap. So for in any compiler, while you are executing the program, it take the memory and divide it into 4 chunks. So first one is the code. So that is the entire main code will be stored in this memory part. So if this program contains any global variables, So that is the variables which are declared before the main. All the global variables will be stored in the external variables will be stored in the a common memory location. After that, here is we are using the stack. If this code is contains any subprograms, but immediately the control will be that the subprogram will be pushed onto the stack. So here is it is the function will be executed in the stack. After that, the result will be again sent to the main program of this. So this is the function of the stack. By default, the stack size is 64 KB. By default, the stack size is 64 KB. But if, so then here is we are using a heap is a empty or unused memory. Heap is a empty or unused memory. But here is a, when you are using the stack, so if the function program size is, so that is the more than 64 KB, so then it takes the memory dynamically from the heap, and next if it is after completion of execution of this space will be added to again heap. Or suppose here is if it program is using only 32 KB, remaining 32 KB will be added to the heap. So that is for efficient utilization, we can use the heap concept. So that's why here is a static memory and it is a stack. Do you know why we are using the stack? But whenever the function call is encountered, immediately the function, entire variables and local variables, parameters, return statement, everything will be pushed onto the stack. Within the stack, it will be executed. After that, whenever that find the return statement, immediately that go to the code. Heap, you see that heap, data that may be outline the call to the procedure to create it. Suppose this is generally you can call it as a free space. Stack allocation is a valid allocation for procedure since procedure calls are nested. So that means in procedure means here is, so that is the functions. We can call it as a functions, right? But in the Pascal they were calling for the procedures and function. In the Pascal, so suppose in the Fortran they were calling subroutines and functions. But now we are using everything is a function in the C programming. So that's why that is the functions when this is the, I have also the dynamic memory allocation at the thing. Suppose when you are using the dynamic memory allocation, at the time of compilation, the stack size will be fixed. And here is in the dynamic memory allocation, it will be fixing at the time of execution, right? So this is the static memory allocation and dynamic memory allocation. For example, you say that a quicksort, how this quicksort will be executing in the memory. For example, int a is a global variable and a void read array. It is in the main program. First it will give the input values to this. This is the one function. And here is the quicksort is a partitioning part. The partitioning part is a one module and quicksort, and that is the main program. So that means this is the function for reading, and these two are the global, and here is the partition function and quicksort function and the main program. But for this one, how the compiler will allocate the memory at the time of runtime. So then you see that entire thing is enter main. First one is C programming that will start execution from the main. That's why enter main, enter read array. After that will be reading input values, because here is we are calling, so that is the read array. The read array means that we will be calling the values from this one. So next one is it set the values. So that is a is equal to a of 0 is equal to minus 9999. A is equal to upper limit and lower limit. We are calling the stack. We are calling the stack function. This will be executing. So that is the quicksort means. But when you are in the quicksort, and that is also calling the partition into quicksort, and next to quicksort and quicksort. So for this one here is in the quicksort will be called next. That is the 1, 9 elements. Enter the partition. So it partition for partitioning, it will call the another function and leave the partition. After completion of the partition, it leaves and enter the quicksort. So that is enter the quicksort of this one. Here is that will be this recursive call, and next quicksort is leave. Again another quicksort will be the second part. Enter leaves, enter quicksort. Enter leave the quicksort and leave the memory. Actually, this is the procedure of execution of quicksort. But here is in that case, how that will active, here is activation tree. We can call here a activation tree representation called during the execution of the quicksort. Activation tree means that is currently that is executing in the stack. That is the control stack elements. So this is the procedure we are taking. First M. So that is the procedure we are taking. Quicksort we are calling 1 to 9. Next partition algorithm. Where next we are calling the partition 9, 1, 9. And next we are calling quicksort 1, 5 quick partition. So that here is we can call and think. But all the things how that will be executing in the stack. But if it is a recursive function, how that will be executing. So that is the first integer will be stored. So next that will enter into the main. After that main to next R value and integer values will be reading. So next here is integer and next that is a calling quicksort and main function of this one. Now you see that activation record, but here is taken activation tree. So the activation tree maintains activation records in the stack, right? So this is the procedure for quicksort, how that will be stored in the stack and how it will be executing, how that will be partitioning like this. Just briefly I explained, right? I'm not going in depth on the theory. So that's why here is we are taking activation record. So that is what do you mean by activation record? So here is in the runtime environment we can use the activation tree. But in the parse trees, so next one is syntax tree, annotated tree. So that is the directed acyclic graph, dependency graph, and next one is the trees of this. So activation record, the tree which contains the activation records is called the activation tree. So activation means procedure calls and returns are usually managed by at the runtime stack called as a control stack. But here is the procedure calls and the return statement. But in every function we can call the function, call function and calling function. That is the procedure calls and the returns are usually managed by the runtime stack or called the control stack. Also that the control stack means the calling of the function or exiting of the function will be done at the time of execution. Then that stack is called control stack. Each live activation has an active record. So that is the while that will be created at the runtime. So that is called activation record. That means activation means the currently executing records. Or sometimes we can call it as a frame also. So suppose if you want to run any video, that will be divided into frames, right? The remaining frames will be idle, but always only one frame will be executing. So that is the one frame like that. The root of the activation tree is at the bottom of the stack. The root of the suppose while you are constructing the tree like this, the root of the tree is always bottom of the stack and bottom of the stack. That means first root node will be pushed onto the stack. The current execution path specifies the current of the stack, while the last activation as record will be stack index. Here this is the activation record, right? But here is whenever suppose if the function is if the program control is moving from main program to subprogram, but what information will be stored in the record, activation record? So that is the thing. This is the activation record. I think you understood that. So in the main program we are calling, suppose whenever you encounter the function call in the main program, immediately control comes to the subprogram. But here is the function will be executing. Within the function, whenever it finds the return statement, again control goes to main program. During this process, what information it will maintain? That means here is the activation record will maintain temporaries. That means temporary variables. Whatever you are creating temporary variables, the temporary variables will be stored at the last phase. So after that, next to local data. Local data means the function variables, local variables. Suppose int a, b, whatever are declaring, that variables data will be stored in the next. After that, a saved mission status. Saved mission status means it is the status of the main program. Suppose when you are calling the function call, the control comes to the main subprogram by pushing the next statement address in the main program. So that will be done like this. Access link. Another one is access link means, but here is when you are using this stack, it cannot use outside variables. So suppose if the function is pushed onto the stack, it cannot use any outside variables like global variables. So if you want to access the global variables, and it also provide the accessing link. It also providing accessing link of this one. Next, control links that we will be taking for controlling the variables. So return values and actual parameters. That means actual parameter means the variables which are that is passed in the main program are called the actual, or that is the function body variables are called formal parameters. So that means the activation record, so that contain this information while the function is executing. So this is the responsibility of the compiler, how the memory is allocated, what information will be stored while you are executing the program in the stacks, right? The temporary memory, local memory, saved mission status, access links, control links, return values, and actual parameters. So the designing cell calling sequences, but how that will be calling? So then function calling will be taking like this, and it is that entire thing will be stored in the values, pulling enough this one corresponding to record. That means here is, so next one is, suppose here is, so for this one either you can use the heap or suppose another, so that is the stack. But when you are using the stacks, or we maintain the stacks, so that is activation tree and activation record, so that we can execute the functions. But in this case, there is a problem is there, garbage collection. Can you use garbage collection? But here is when you are using this garbage collection, so for example, you see that, for example, when you are using the stack, there is no memory loss, because while the pushing and popping operations can be performed only from one side, so that's why there is no loss of memory, but it is a good. But sometimes when you are using the dynamic memory allocation or heap sort, that is a heap memory, that heap memory is a partition into a number of sub parts, sub memory. But that is a partitioning algorithm. I think in the operating system we have studied it. Internal fragmentation and external fragmentation. So that means that the fragmentation means the unused memory. So suppose if the memory is divided into a number of subparts, or within the subpart, the memory is wasted, that is called internal fragmentation. So that is the overall memory management is called external fragmentation. But here is, but whenever you are using that, for example, in the C programming, you allocated memory for 10 pointers. After that, you are not using a free operation. That means you are not deallocating. So that memory will be always in the leakage. That cannot be used every time whenever you are executing that. Providing that, so suppose here is in the Java, we can use the Java collector. But in the C programming, there is no garbage collector. Garbage collector means, so it collects the unused memory wherever it finds, and it will add it to the heap. It will add it to the heap. So that is the garbage collector. But the C compiler or C++ compiler doesn't have any garbage collectors. But even when they are using stack memory, stack operations, that's why, so they are also performing efficient garbage collections, right? Garbage collection means, so that is the stack without using the memory will not be wasted like this. But automatic garbage collection will be done in the Java code. So already we know that Java is a garbage collector. That means, so that is the program is easier if the runtime system has garbage collector. While at the time of execution, so it garbage collector searching, the compiler will searching for free space. If it find any free spaces or anywhere, immediately that bring the free space and added it to the heap, so that at the time of execution we can utilize the memory properly. So that is called garbage collector, right? So internal fragmentation and external fragmentation will be added to the, so that is the heap. That is the wastage of memory is automatically collected at the time of execution, and next that will be added to this. It makes space belonging to unusable data available for reuse. Java does it. Already we know that Java is a character. C does not do it. But here is we have to use the stack operations only for collecting the garbage data. But stack allocation in C gets some of the advantages. But while we are using the stack for implementation of compiler in the C compiler, so that's why there are some advantage. Speed. That means stack means it is a speed. Low overhead of for garbage collector. But when you are using the stack, there is a no garbage collector because there is no garbage because always the values are pushing onto the stack. But there is a no chance of wasting of memory. So if you implement the stacks dynamically. So little program interruptions, little program interruption. For now there is no program interruption in the C. Many collectors shut down the program to hunt for the garbage collectors. So but here these are the two advantages, speed and then little. But another case, the garbage collectors also there. Suppose in the operating system will collecting the unused memory, but how that is collecting, suppose whenever it is collecting, but entire program will be shutting down. Restart, well, suppose you can see that, suppose you take Windows 10, when you sit down that program, so at the time of rebooting, automatically it takes more time because it collects the, so that is unused memory and the proper setting of instructions or software like this. It scans the memory. But here is at that time system will be shutting all the programs. But here is at that time we can't work on that, we can't do like this. So that is the main. So that is the locality. Data that is used is placed on pages or cache lines, right? So that is the, so these are the drawback of that. That's why we have to go for a separate garbage collectors. So that now we are using Java, so the Java programming or as well as in Python they are using garbage collectors. That is the virtual. So the taxonomy of this garbage collector is reference counters we can use, trace based counter we can use, stop the URL, stop pass, that is the mark and swap, basic and Baker's algorithm, and mark and compact are different types of garbage collectors available in the Java. But what I mean by garbage collector, already I explained that. Garbage collector means, so that is unused memory, either internal fragmentation or external fragmentation will be collected at the right time of execution and it added to the heap space. But how the compiler will identify either that is a unused memory or wasted memory. So for this one, here is a garbage collector. It can use a separate counter. It can use a separate counter. For example, reference counter. One is the reference counter. So reference counter means, so for the particular memory, for particular, suppose if the memory is somewhere that is some variables are allocated that memory, at the same time, so compiler, so assign one counter, a reference counter. So then, so the reference counter will be making down. Suppose every time that will be reducing like this. Suppose if you are using that, so it will be activated. Again it will go to the maximum value. So suppose if you are not using that variable, so that is a long time, so that is the count reference will be reducing. Whenever the reference counter is equal to 0 for that memory location, then compiler will identify it as a unused memory, then that will be added to heap, right? Like this, it will count. Suppose, so in the, suppose the running race or some other competition we can use like this, 10, 9,